lunch. I hope we all had great lunches around here. This talk is how to build a plan to migrate to Python 3, which I think is super timely, and the clock's ticking on that. Philip is going to talk about it and tell us how to migrate to Python 3. So, Philip.
Thank you very much. Thanks everyone for being here. I really appreciate it. I also want to give a shout out to our volunteers who are helping make things happen into PyOhio in general. So this wouldn't be possible without you. And I especially want to thank you all for showing up here and checking out what I had to say. So I'm here to talk about migrating to Python 3, and I hope you're here to hear about the same, because if so, then we got a thing going on. We got something in common already. It's a good sign. A little bit about me. I'm a software developer, have been for a very long time. I started doing it. I got a computer science degree in college, graduated in 1989, and I was doing computer stuff before that. So I've been a nerd for a very long time is what it comes down to. And I'm still doing it. I still like it. I'm a freelancer. I work for myself or for my clients. I could work for you one day if that would be of interest. So that's my LLC down there. And one of the other things I like to do is photography. So that's my photograph up there. I'll show you a couple of my photographs as the talk progresses. And I do want to say a couple of things about the structure of this. Is that one is that this talk is based on a blog post that I made on my blog, which you can find at pyspoken.com. And it's actually, the blog post is pretty short, but there's a very long PDF in there that contains a lot of the details that are in this talk. So you are welcome to take notes and that sort of thing during the talk, but actually a lot of it is in that PDF, and I'll put these slides up on my website after the talk is over. So feel free to take notes, but you probably don't need to all that much. Another thing is that I'm here just as much to hear from you as anything else, because really, if I just wanted to blather information out, I'd say go to my blog and look at the PDF, and it would be a 2-minute lightning talk and I'd be done. So it's much more about me talking to you and getting feedback. So please feel free to interrupt with questions and comments and observations. And I'm hoping to leave 5-10 minutes at the end or something so we can talk a little bit more. But feel free to stop me during the talk. I think that's all the business I wanted to take care of. I've been using Python for a number of years now, and like many of you, I started off in Python 2 and have been thinking about Python 3, and sometimes using it, sometimes not. As I said, because I'm a freelancer, I have a lot of different clients, and I don't necessarily get to choose what version of Python I work with. I work with what they're working with. So I got to thinking about this subject, and this would be a good idea for a talk because, because of this photograph up here, which provides a lovely segue into our topic, because what we're talking about really is a sunset, right? The sunset of Python 2, which has treated us so well for so many years. And it is actually coming to its end of life. The actual official end of life has been announced. It's January 1st of 2020. So at the end of 2019, Python 2 is no longer going to be supported. And that doesn't mean all your Python 2 projects are going to go poof and stop working, but it does mean that you're going to be running on unsupported software. So not even any security updates, anything like that. So it's something to keep in mind. Python 2 is really stable at this point and pretty featureful, but it's riding off into a lovely sunset, kind of like those seagulls there, or whatever metaphor you choose to apply. So, geez, we've been through all this stuff already. So let's go on to the next part. Why Python 3? So I'm not going to do a lot of Python 3 advocacy in this talk. I really don't feel like I have to. Python 3 is great. And really the main reason that you want to think about Python 3, if nothing else, is that one at the bottom there, that Python 2 is going to go away at the end of 2019. But Python 3 is really great if you haven't used it. So it's mature. It's been around for about 10 years. I didn't realize that until I started doing the research for this presentation. And I know that maybe some of you who are around for the early days of Python 3 used the very early versions. Very early versions of Python 3 were pretty rough. And I think some people may have gotten a bad taste in their mouths from using those early versions. But Python 3 has stabilized quite a lot now. And it's got some really nice features, not the least of which is the sane Unicode handling, which is not really present in Python 2. And plus the standard library has picked up a lot of cool new features. So there's some really compelling reasons to move to Python 3. And I think a lot of organizations are simply stuck on Python 2 out of inertia and out of partly fear of what it's going to take to make the transition. And what I want to talk to you about today is to say that that transition actually doesn't have to be too big or too difficult, and you can break it up into little chunks that are very manageable and tractable. And when you actually comes times to make the final transition from 2 to 3, it doesn't have to be that big. It's sort of like if you imagine maybe something from like the Ministry of Silly Walks, where at first the step you're going to take seems like this big awkward step where you're going to land awkwardly and not feel good about it. And what I'm trying to look at this is instead is you can actually make this transition as a number of small steps, feeling safe and comfortable all the way, even if you're trying not to get too far away from the microphone. And then when it comes time to make the last step, it's just a small, comfortable step. So that's what we're going to talk about today, is trying to make this a manageable transition. And we're going to develop, or I'm going to give you an outline that you can fill in for your organization, because everyone is different. If you're working for a bank and you've got lots of users and you lose $1 million a minute if your website is down, that's a really different organizational needs than if you're, say, working in a science lab where you've got 10 users or something like that. And if things go funny for 3 days, nobody cares because you can do something else. I can't really tell you what your organization is like or what you need to, how you need to manage this transition, but I can outline the steps that you need to think about, and that's what we're going to do today. One of the assumptions I make is that you don't want to support 2 and 3 simultaneously. That's certainly possible to do, but it's a need a lot of people don't have, and since 2 is going away, I'm more thinking about making this clean transition to 3. So that's certainly possible to do, but I'm not going to talk about it very much here. And one of the main points I really want everybody to remember is that you can start a lot of the things I'm going to talk about, you can start them today. Maybe not right in this talk, but as soon as you get out of this talk, you can start. And that's nice because it means that you've got this 18-month window before Python 2 actually goes away. And so you have a fair amount of time to start making things move and getting things moving towards a nice, stable transition. So 18 months might seem like a lot of time. If you have a big organization and a big project, it's not actually that much time because you have to go to your manager and ask for time and ask for budget and think about how all the pieces are going to move together. So it's not at all too early to be thinking about that. So the first thing that I recommend you think about when you're deciding how to make this transition is which Python 3 you want to target. It might seem obvious to use the most recent if you can, and that's good advice. Python 3.7 just came out like a couple of weeks ago or something like that, right? So yeah, so 3.7 is available. Obviously, it's got latest and greatest features and new stuff in the standard library. Some organizations are going to have restrictions on what they can do. For instance, if you are building code that's going to run on a scientific computing cluster and you don't own that cluster, you don't own the Python that's on it, it might be that whoever administers that cluster only has, say, Python 3.4 on it, so you need to target Python 3.4. So this shouldn't be too hard of a decision to make. It's mostly about what freedom you have available to you. Obviously, the newer Pythons are going to offer some better performance and features. Also, something to think about is that if you are going to invest in this transition, you may as well make a move as far as you can into the Python present because it doesn't change the cost of your migration. It only changes how far you get. And I had mentioned briefly before that the earlier Pythons, the 3.0 and 3.1 and 3.2 were pretty rough. So I doubt there's any reason you'd get stuck targeting them, but if you find that that might be in your future, fight hard against that because they were pretty rough. Stay away from them if at all possible. So the next thing that you probably want to think about as far as making this transition is identifying what gaps you have in your test coverage. So I'm sure there's some of you in here who have 100% perfect test coverage, and to all of you, I apologize for boring you for the next 2 minutes while we talk about this, but for the rest of us who don't have perfect test coverage, we have to think about what problems might slip through the gaps when we make this transition from 2 to 3. What's likely to break that's not going to get caught by our tests? And I would say, you have a question?
Are there any tools for diagnosing how much coverage you have for your code base?
Yeah, there's a tool called Coverage.
Oh,
that is not specific to the Python 2 or 3 or this transition or anything like that. But yeah, there's a tool called Coverage, which is written by, who wrote that? Ned Batchelder? Yeah, okay. I've used it before. I like it. I think it can be a little misleading sometimes because you can write a really lousy test that all Coverage does is it says, was this line of code executed during a test? And so you can write a really lousy test where it runs a lot of code, but at the end just says, did it fail or not? And it doesn't really tell you whether or not all the things that are supposed to be happening actually are happening. But it does at least give you some honesty. You know if a line of code was not executed, then it wasn't tested. So yeah, it's a pretty popular tool. Thanks for asking the question. So as long as you don't have that 100% test coverage, what I was thinking would be two really good areas to focus on are text handling, because I think probably everybody's aware that Python 2 and Python 3 handle text differently, especially with regards to bytes versus Unicode. The handling in Python 2 is data dependent, and in Python 3 it's type dependent. So you're more likely to get hard errors in Python 3 where you could get away with some sloppiness in Python 2. I shouldn't even say sloppiness. It was just things that Python 2 permitted that Python 3 doesn't. And usually once you get data into your application, if you handle it consistently, once it's inside there, you're not going to have trouble. So I would say focus on your text handling where around the borders, where stuff is coming into and out of your application. So think about file input and output. Think about getting stuff from emails or off the web, anything like that. Even think about log files, because we might not think of log files as log files. It's just a log, but you're writing data somewhere to a disk, and that's an opportunity for Unicode and byte mishaps to happen. So that really should be your main area of focus. Division also changed a little bit between Python 2 and 3, and that is probably not going to be a big problem for most people. We generally do not very much division in Python programs unless your program is really math heavy, in which case you're probably using NumPy and it's less of an issue there. But if you have maybe like a little progress meter in there or something like that, the way division is handled in Python 2 and Python 3 changed. And again, it's a difference between being data dependent being versus type dependent. The difference between these two is that if you mix the wrong types of strings together in Python 3, it will raise an exception immediately. Whereas the way the division operator changed, it'll still divide, it'll just give you a slightly different result. And that can maybe give you a sneaky bug. The other difficult thing about division is that the operator is a slash, and it's really hard to grep through your code for slash to find meaningful uses of that. So that's just a tough one. So a third thing that I suggest you do when you're making this transition is to review your dependencies. And I want to pause for a moment and say that I realize I'm numbering these. We talked about the idea of deciding which Python 3 you're going to target and reviewing your test coverage. And now we're talking about reviewing dependencies. And you might say, hey, Philip, I heard you call them first, second, and third. So why didn't you put numbers in the headings? That would have been an obvious choice. The reason I didn't do that is because I don't want to give the impression that these things have to go in a certain order. You can do all of these simultaneously. You can, if you have a big group, you can have one group reviewing your dependencies while somebody else is trying to figure out what Python 3 you can target. So the nice thing is none of these are dependent on the other. You can go at all of them at once. So that's why these aren't numbered. But it's the third thing I'm presenting, so I'm going to call it the third thing. And that's reviewing your dependencies. And there is a nice tool for doing this. It's called Can I Use Python 3? And the way that tool works is you feed it your requirements file, your requirements.txt, and it runs through that file and has a look at all of your dependencies and goes up on PyPy and makes sure that the package metadata there says that the package supports Python 3. And it even checks your dependencies. So it goes through the whole tree, and that's great. There is one problem with it, which is that it relies on the package author to supply accurate metadata. And not all package authors do. Sometimes package authors don't bother putting metadata up there, or sometimes they let it get a little bit out of date and things like that. So this tool is sometimes a little bit too pessimistic, and it will say that your package doesn't support Python 3 when it actually does. So that's the good news, is that if you run this tool and it spits out this long list of packages that you might need to upgrade, don't panic immediately. There's plenty of time for panicking later, and just go through the list and make sure that it's actually accurately reporting what you need to address about your packages.
Can I ask,
Yeah.
does it review the dependencies as whole, or like a dependency with the version number? So if I'm using request.
That's a good question. It uses the actual version number, so it goes and looks up the package metadata for that particular version. Actually, I take that back. I don't know for sure, but I would be a little bit strange if it didn't do that, because it's very well suited to, the requirements.txt file, so does such a nice job of making that easy to parse. I would imagine it just goes to that PyPy version and pulls down the metadata for that version. That would be the sensible way to do it anyway. I hope it works that way. So another thing you can do to prepare your code for Python 3 is to start making your Python 2 code more Python 3-ish. So there are 4 from future imports, and what they do is they change the syntax of the module they're imported in to use more Python 3-ish syntax. The first 3 are not all that exciting. The last one, I think, is probably the more helpful of the 4. Unicode literals just means that every literal that's in the file will be automatically Unicode. You don't have to put that little U in front of it to make it Unicode. And that's nice because it helps keep you honest about what is and isn't Unicode in your code. And as you're flinging strings around, they're better prepared to handle the mixing of Unicode and bytes. I have been just slapping these 4 imports in every single new file I've written for a number of years now. And it's just getting me habituated to expecting Python 3 syntax, even in my Python 2 code. So I recommend it for all new code. If you put it into existing code, it can change the way that code behaves, right? If these imports didn't change code behavior, they wouldn't be interesting. So if you put them in existing code, you can break your existing code. And so I have a hard time recommending it for existing code unless you do a lot of testing. And maybe you really want to make that testing explicitly about Python 3 testing. So I'm not sure that I recommend it for existing code. But there is a lot you can do for existing code, and that's what I'm going to talk about next. I'm going to spend a fair amount of time on that because generally in these projects, that's one of the big time sinks is taking all your existing code and changing the syntax to be Python 3 compatible. So the good news is there's a really nice tool for that, and it's called 2 to 3. It's part of the Python standard library. There's actually a 2 to 3 module that's part of the standard library. Most people don't interact actually with a module. They interact with a command line utility that's a thin wrapper around the module. So that's what I'll talk about is the command line utility 2 to 3. So 2 to 3 consists of about 50 fixers. That's the term that the module uses. And what these fixers do is they fix a little part of your Python 2 syntax to make it compatible with Python 3 syntax. And it's a really handy utility. It does a nice job. Basically the way it works is you tell it to apply 1 or more fixers. You can tell it to apply all of its fixers. And it prints out to the standard out a diff of what changes it wants to make. And you can even look over those changes and say, yeah, these are good, and even tell it to write over your files in place if you want. Or you can take the diff and go through it by hand and apply the changes yourself, maybe apply some, reject the others. So we're going to go through this handy tool in some depth because my recommended way of transitioning your code. So one of the things that's not in the 2 to 3 documentation that I wish was, I think would be really helpful, is that there's really 3 categories of fixers, and I've divided them up this way. There's fixers you can run now, meaning that you can run them immediately and they will change your code, but they won't break your Python 2 syntax compatibility. So you can run these and your code will just be that much more Python 3 compatible, but it'll still run just fine under Python 2. And then there's a second category I call now with review, which are also make changes that are compatible with Python 2, but some of the changes are a little bit not always desirable, or they might just be not very useful. And in really, really rare occasions, they can break stuff. So these are ones that are operating on slightly trickier bits of Python syntax, and I recommend you review the changes. And then the last category are the ones you need to do later, which means that once you apply those fixers, your code is not going to run under Python 2 anymore. So those are the ones you want to wait till you say, okay, today is the day. Today is the day we're going to migrate the code to Python 3 and we're shutting off Python 2 compatibility. So I'm going to go over all three of these categories and we'll see what they're like. But first, I want to take a short break and get a drink of water, so I'll give you something a little interesting to look at. The dumpster is in beautiful Carborough, North Carolina, where I'm from.
Right behind where you took the first picture.
That's right. That's how life is, isn't it? You look behind the facade and that's what you get. No, it's actually next to a Chinese restaurant and a really great Belgian bar. So if y'all ever want to come visit, we can go look at the dumpster and have a beer. Hopefully in that order. Yeah, that's right. Yeah. So getting back to the 2 to 3 utility, remember there's the 3 categories of fixers we want to run. And I'll go over the now fixers first. These are the easy ones. There's lots of them. About half of them fall in this category. And I'm not going to go over all of them except for one, just to give you an idea of what a fixer does, what a fixer is like. So we'll go over the knee fixer. And I really wish I could say it was about this kind of knee. Unfortunately, it's a lot less interesting. It doesn't involve shrubberies or anything like that. The knee fixer is actually for not equals. So you might not even be aware that Python 2 supports 2 kinds of not equal symbols. It supports this, the double angle brackets, and also the bang equals comparison. And Python 3 only supports the latter. So all this fixer does is it takes every instance of the former and converts it to the latter. So that gives you an idea of what a fixer does. Tiny, tiny little changes. And that's kind of nice because that means each one is very narrowly targeted. So that's it. That's the whole not-e fixer. And there's 49 others like it. So I lied a little bit. I said that there were 3 categories of fixers, and there's actually a 4th. There's what I call the now or never one. There's this one fixer called the callable fixer. You only need it if you're supporting Python 3.1. And if you have to support Python 3.1, you got bigger problems than I can address in this talk. So I hope nobody here has to deal with that, but there's that category. So the second real category, we'll call that one 1A, and this is the number 2. These are the fixers that you can apply now, but I do recommend that you review the changes they want to make because they work on trickier aspects of Python syntax where the changes aren't so straightforward, and sometimes the changes the fixer recommends are benign but add clutter to your code, or as I said, in rare cases, they can be harmful. So I do want to go over just one of these fixers to show you where it can be useful and not so useful. And I picked the dict fixer. So the example of this is that what this fixer does is it wraps calls to dictionary methods in calls to list. So in Python 2, if you call a dictionary method like keys or values or items, it returns a true Python list. If you call type on what it returns, it's an actual list. Python 3 doesn't do that. Python 3 returns a slightly different object. So if you call a dictionary.keys under Python 3, you get back a dict_keys object. And you can iterate over it, and in a lot of ways it acts like a list, but it's not a list. And so you actually need a list. You're getting back something else. So what this fixture does is there's the before and after code there. The after is what the fixer has done for you, is wrapped your call to keys in a call to list. However, this is a case where the fixer has not really helped you out because both versions of the code are valid in both Python 2 and Python 3. In the upper version, if you call that under Python 3, that'll work just fine. You can iterate over the dict keys object, and that's no problem. So the change that the fixer has made is actually not that helpful because it's just added a call to list, and it doesn't really hurt anything. You could argue that if there's like a 0.0001 performance hit or something like that, it doesn't really matter. It does add clutter to your code, and so I'd argue it's not a desirable change. But let me show you another example where the dict fixer is actually really helpful. In this top example, this code is only valid in Python 2 because this relies on the fact that the keys method is actually going to return a real list. In Python 3, if you try that, you'll get a type error. It will say, sorry, I don't know how to concatenate a dict underscore keys object with a list. And so after the fixer has run, then your code will run equivalently under Python 2 and 3. So that's an example of a case where the fixer is really helping you out. So the last category of fixers I want to talk about are these later fixers. And these are the ones that are going to take your code and change it so that it will no longer run under Python 2. And most of them are actually not that exciting. They're targeting really narrow parts of the syntax, or they're just very, very straightforward. However, there is one, the Unicode Fixer, that requires some special attention. So we'll talk a little bit more about that. And just for completeness here, there's the list of the later fixers. As I said, they're all pretty boring. The Unicode Fixer is the one that we want to pay attention to. So the Unicode Fixer is a little difficult. I guess you could say it's not my favorite fixer. I don't really know that I have a fixer, but this is not it. It does, one of the things that frustrates me a little bit about it is that it does two jobs, and one is completely benign and the other one is not so much. So the first job it does is it strips that little U prefix off of all your string literals. Python 3, that U prefix doesn't hurt anything, but it's also just clutter. It doesn't help you out. So this fixer is doing the right thing by getting rid of that for you. The second job it does is it takes all of the calls to the built-in function Unicode and converts them to str, or string. And it has to do that because the Unicode built-in doesn't exist under Python 3. However, that can also change the behavior of your code. So this first change it does is meaningless and harmless. The second change it does can change behavior. And the reason it can change behavior is because when you call the Unicode built-in on an object, let's call it X, you have Unicode X. What Python does under the covers is it calls a dunder method, a double underscore method. So it actually calls x.__Unicode__. And if you've written one of those methods and actually have custom code in there, then it will get executed when you call Unicode on your object. However, when Python changes that or when the fixer changes that call to Unicode to a call to string, your Unicode method isn't going to get called anymore, and the behavior object is going to change. It's going to convert to string in a different way. So that's breakage. The good news is that there's smarter people than me have encountered this a number of times, and they created this nifty little decorator called Python 2 Unicode compatible, and it's available from a couple of different open source projects under a very liberal license. And what it does is, I won't go into the details of how it works, but it allows you to write your classes in such a way that they will work smoothly under both Python 2 and Python 3 and support being converted to plain old string and also to Unicode. So once you've applied this decorator to your classes and made the necessary changes, then this fixer is benign and harmless, but not until. So this fixer requires a little bit of advanced prep to make it useful. We good so far? All right. Everybody staying awake after lunch? It's tough, I know, after lunch. You're going to food full of, stomach full of carbs, and everybody's trying to digest all that food and pay attention, digest my talk. So I appreciate you staying with me here. So at this point, we've talked about all the steps. I have before mentioned taking a bunch of little baby steps to get yourself closer to Python 3 compatibility, and we've done that so far. We've gone through all these steps about reviewing which Python that you want to, which Python 3 you want to migrate to. Talked about looking for places where your tests might leak and not tell you what's going to break. We talked about reviewing your dependencies, and we talked about how to use 2 to 3 to convert your code to something that's Python 3 compatible. So at this point, you are in good shape to actually finally do the 2 to 3 migration. And this slide, as you can see, is pretty much one of the emptiest I have. And that's because this is the step about which I have to say the least. It's because it's very organizationally dependent. I had mentioned some examples before, like for instance, if you work for a bank where the stuff hits the fan, if your server goes down, you want to make a very, very careful transition and have a backup plan in case the transition doesn't go well. And you might want to have half of your servers running on Python 3 and the other half running on 2 and transition them gradually. Or you might work in an environment, you might be working on your own personal project where if it breaks for a week, you don't care because you can just attend to it as you see fit. So the way you want to make this migration and how much care you want to put into it and how you actually want to make the transition is really up to you. All the steps you've done before have made this as easy and as small of a step as possible. but the risk that you're incurring when you take that step is really something that you have to manage about your project and your organization. So I had posted this on my blog, as I mentioned, and somebody on Reddit picked it up and posted it there, and it generated some conversation. The commentary wasn't as positive as I would have hoped for, and however, it was interesting, and the reason that I'm posting it here is because it generated some interesting thoughts. So this gentleman, and actually, Kenkyo, actually, he is a gentleman. I went and looked him up and talked with him a little bit. I wish he had been a little bit more positive, but I did appreciate his comments. And it turned out that just a couple of days later, he posted to his own blog his own experience with migrating from Python 2 to Python 3, and it's a really interesting blog post. That's the URL. If you want to Google for Hofmuller Python 3, you'll get to it a lot easier. His criticism of what I had recommended is that I didn't recommend using the library 6. So 6 is a compatibility library that will allow you to run your code under Python 2 and 3 simultaneously. And as I said, that is something that for most people I think is not necessarily an issue. The way that, if you read his blog post, the way he describes the way they migrated their code is that they immediately integrated 6 and then started running all their code under Python 3 just to see what would break. He said it took them about a year to make the transition from 2 to 3. During that time, then I guess they had simultaneous Python 2 and 3 branches to maintain, which sounds to me like a lot of work. It was, yeah, right.
Sorry.
No, go ahead.
I was going to bring this up in the questions.
Okay.
I wouldn't expect that they had separate branches to maintain. You have a single branch that uses 6, and so you can run.
Oh, right. Yeah. I see your point. Yeah, so just a different environment. Yeah. It's a good point.
I mean, that's what's essential about using 6 if you have a very large code base, because if you have, unless you're willing to stop development, move to Python 3,
Right.
have flag day, and start development again, it's impossible to go from 2 to 3 without using 6.
Yeah. And that's that was his point, and certainly that applied to him because he had 250,000 lines of code to deal with, and some of it was really, really old. So I think it's good advice if you do have a big project like that, but it's not something that I've had to deal with personally, and I think that was very, very fresh for his experience. So it was a big deal to him, and I think that's why he was so negative about what I had said. And fair enough. I'm sure that all that pain was fresh for him. So at any rate, I do recommend you read his post. It's pretty informative. One of the interesting things he said in is they tried to use 2 to 3, the utility I had recommended, and he found out that it broke their Python 2 code, to which I said, yeah, actually, if you'd had the opportunity to see this beforehand, you would have known that and maybe gotten a little less burned. So I think that they gave up on 2 to 3 pretty quickly. So that was unfortunate for him. I wanted to mention a couple of other utilities that you could consider. There's Futurize and Modernize. I have not used either one of them. Modernize, I gather, is a little bit older and has maybe not received as much recent attention. There's also Futurize, which is more modern, but is still based quite a lot on 2 to 3. It does introduce a compatibility library that's not 6, but I think is quite similar to it and does a similar job. So you might want to look into them as helpers. 2 to 3 is nice if you're controlling it on your own, because one of the things you can do is you can run the fixers bit by bit and control how you commit those changes to your version control system if you like. So you can commit all the changes from one fixer, or do a bunch of them at once, like maybe all those fixers I showed you at first, all 24 that are pretty much harmless. You might want to commit all of them at once. So I prefer using 2 to 3 just because it offers you a little bit more fine-grained control. So that is most of what I have to say. Just a reminder that Python 2 has about 18 months of life left in it, give or take, and it's probably time to start thinking about how you're going to make that transition to Python 3. And I really hope that this talk has given you some ideas about just what you need to consider. I should have mentioned that the reviewing your dependencies is probably one to do pretty early, just because if you do have dependencies you find out are not available in Python 3 and they don't have easy substitutes, that can be a place where you might end up spending a fair amount of time and you might have to rewrite a bunch of your code to work with a new library that you're forced to adapt in the transition. So that's a good one to start with. But the good news is you can start doing all of these right away and bringing your code closer to Python 3 compatibility. So even if you don't need all 18 months, you can get a lot closer in the next few. There's different ways to make this transition. If you're of the move fast and break things school of thought, then you can just jump into Python 3 right away and see what breaks. If you're working for maybe like a medical device company, especially a medical device that I might use someday, I would like for you to take a little bit more time about the transition to make sure it goes smoothly. But that's up to your organization. As I mentioned, this is up on my blog, and there's a big associated PDF that has a lot of what was in this presentation. Because I am a lazy blogger, I think that's still the most recent post on my blog, so you shouldn't have too much trouble getting to it. And by this evening, I'll put up the slides from this talk as well. So it looks like we have some time left over for Q&A. I do want to explicitly thank you all for coming out and thank PyOhio for hosting us. So really appreciate it. So, yeah.
So we use Django framework, and
Mhm.
I know that we don't have 100% coverage in testing. And so what do you suggest that we do first? And we do Python upgrade first, or the coverage test first, or the Django upgrades first, or how would you see that?
Do you have any idea what test coverage you have right now? What percentage is it? Not a lot, yeah.
Not a lot, yeah.
Coverage is not that hard to integrate, and so it might be good just to give yourself a baseline. And if you find out you have 50%, then you say, that's not great. If you have 5%, then you might say, oh, that's pretty bad. We need to address that first. And then decide what effort it would take. Maybe you can get yourself up to, say, 20% coverage, which still isn't great, but it's a big jump with a minimum of effort. So maybe try to find the sweet spot into how much greater test coverage you can get, and especially with that focus on what is most likely to break under Python 3. So again, you know, Unicode handling is a big one. And that's where I would start, is assessing where you're at and then figuring out where you need to go from there. Yeah.
Just to comment on that,
Uh-huh.
Instagram had a talk in PyCon 2017,
Uh-huh.
specifically migrating from the Django 1.3 to 1.8
Oh, that's great.
into Python 3, and they
Yeah.
have like a roadmap of how they approach it.
That's
It's a
good.
monolith application, so it's pretty swift.
Uh-huh.
So I was gonna bring that up as well. It's a keynote, it's definitely worth watching. I used that as a blueprint to migrate a client from 2 to 3 last year.
All right.
It was, I haven't read this blog post that you mentioned at the end,
Mhm.
or whatever.
Yeah.
But presumably it's similar. So it's a larger code basis where you need to run both at once.
Right.
And it's about, the TLDR is that you basically add Python 3 to continuous integration ASAP,
Mhm.
just to see what starts breaking.
Right.
And but you still allow your build to pass even if Python 3 is breaking. You gradually fix stuff on the Python 3 side.
Mhm.
You kind of ratchet it down, and then eventually you flip the switch and you say, okay, no new code can break Python 3 anymore.
Right.
And then you work that down, so you're gradually moving it over
Yeah.
until you trust it. Use CI as your choke point for that, and then eventually you start running in production and gradually hitting the bugs there. But anyway, that's definitely a good. It worked for me.
Yeah.
Instagram's blueprint. Yeah.
Sounds like a great
As well.
approach.
Yeah.
I think that the nice thing about considering this migration is you're going to have a lot of company, because there's plenty of people who have been running Python 2, and let's face it, Python 2 works pretty well. Python 3 is better, but it's not so compelling that you want to drop Python 2 like a hot rock. So I think there's going to be a lot of people in the next year or so having the same conversation, and so that's why I enjoy hearing others' experiences. So, anything else? Yeah.
Just an anecdote actually about a sort of forced migration from 2 to 3. IT at my former employer decided to upgrade the OS of the production servers, and the new version of the OS had 3.6, but not 2.7. So migrating a bunch of stuff to 3.6, backfilling an install of 2.7. I would not recommend that. I think what you've seen today is far, far better than that experience. And there were definitely words between the dev team and the chaos monkeys in the operations team. So just an anecdote for whatever that's worth.
Have you written that up as a blog post? Because I'd read that.
War story.
Yeah. Yeah. Yeah.
I do think it's interesting that the original imagined use cases for 2 and 3 was actually not described here.
What's that? Oh,
That could be applied during packaging.
aha,
So you could
interesting.
create a Python 3 package in addition to a Python 2 package.
Right, and 2 to 3 would convert it. Yeah,
Using 2 to 3.
interesting.
And so it would not be something where your code was expected to run on both. It would be converted.
I hadn't known that about 2 to 3.
So that can be painful too.
Right, all right.
Yeah, that was certainly one of the early imagined expectations. And there are people who've done
Interesting.
various degrees of success.
And there are still packages that build that way. But that is its own coding style as well.
Mm-hmm.
That you have to test that way. And
That's right. It's a long iteration cycle.
yeah. Well, a little bit of black magic involved of going backwards and trying to figure out, like, this is why it sort of becomes impractical, because code generation is sort of impractical if you want to edit code. Like,
Mm-hmm.
Yeah, that's why 6 was well received.
Yeah, fair enough.
Philip, how about a show of hands who's already migrated to Python 3?
Completely or multiple hands?
Well,
Yeah,
one project
exactly.
or another, you know? And so then everybody else is gonna migrate to Python 3?
Yeah, right.
Well, good luck.
Yeah. We'll see you all here next year, exchanging war stories,
Yeah, there we go.
I migrated to Python 3 and this is what happened.
This is
if
on
anyone
the
else is trying to maintain compatibility with both, I'd be talking to you.
All right.
Because the entire conference dedicated to 2 to 3.
Yeah, probably.
Well, I mean, we've been using 6 a lot, but there's actually some really hard problems with maintaining compatibility with both. It's an interesting problem, but, you know, we have a mandate to live in a time machine at some level for experiment reproducibility for our research, so I can't mandate.
Yeah.
I have to be able to give a researcher a thing that existed 10 years ago, and so I don't have a choice. But I don't want to maintain 2 code bases, so we're trying to tackle that one head on.
So we got about a minute and a half left. Does anybody else? Yeah.
This is kind of related, but maybe tangential. Like some maintainers of maybe small packages are kind of resisting. Yeah, I mean, they're like, Python 2 is it. I'm not interested in Python 3. Do you have any thoughts on that?
They're welcome to that, especially if they're volunteer maintainers. And they're just going to get left behind at some point. And I guess if their package is valuable enough to people, somebody's going to pick it up and say, well, you might not want to bring this to Python 3, but I'll bring it in for you. And maybe they'll want to maintain it then once they're in once somebody else has done the work. But yeah, I can understand people have been on Python 2 for a while and they might not appreciate the sort of feeling forced to Python 3, the shotgun migration. But it's a better world once you're on the other side.
Well, I think the issue is more that we have to support legacy systems, right? We still support our heads
Yes.
off. I mean, it's not realistic to say you're going to ban Python 2. We have systems running 2.6.
Right.
You can't support that anymore. You gotta get paid.
Yeah. Well, anyway, it sounds like maybe everybody should all continue this conversation out in the hall or somewhere. It sounds like we have interesting stories. Thanks a lot, everyone. I really appreciate it.